Basically, if you think about medicine, medicine focuses on the prevention and treatment of diseases, right? And this is usually done with drugs. And drugs are molecules, biomolecules that have some biological function. So chemistry, biochemistry is key in medicine. I think we all agree on this. But this is the only key. That's a question. And actually, so the topic of this discussion, or the question that we want to discuss here jointly, is whether physics can actually contribute new conceptual approaches to advanced medicine. All right, so basically the question boils down to, does the idea this Max-Planck-Zentrum is based on make sense? A little spoiler alert, I will not accept a no as an answer. All right, and before we start the discussion, I would just like to briefly introduce our discussion partners here. So I'm very excited to have 5 very distinguished people here with me, who both wear 2 hats. One's a hat as a scientist, so they're all scientists, but they all wear also a second hat, and I will go through it quickly. So maybe we start with Joachim Hornegger, who is the chair of pattern recognition at the technical faculty of the FAU in Erlangen. And he's also the president of this university. So he has a head as a scientist and a head as somebody who runs the university. Then next to Joachim is Anja Bosserhoff. She's the chair of biochemistry and molecular medicine, also at FAU. But Anja also served on the scientific commission of the German Science and Humanities Council, so Wissenschaftsrat, which is one of the most important science policy advisory boards in Germany. Next to Anja, well, I don't think I need to introduce Randy again, but I just want to mention that in addition to being like a Howard Hughes Medical Institute investigator and professor for cell biology at Berkeley, Randy was also an editor-in-chief of PNAS for a number of years, an editor of an annual review journal, and also, very importantly, the first editor of eLife, which he helped launching, which was a major achievement, I believe. And he's an ambassador for open access publishing in science, and he's fighting what I personally consider a very, very damaging concept, especially in the life sciences, the impact factor. Well, yes, and you won the Nobel Prize as well. So on my left, Karin Jacobs. Karin is a professor of soft matter physics at Saarland University. And as a side job, she's also the vice president of the German Research Foundation, so DFG. And finally, Markus Neurath. He's the director of the Medical Clinic 1 in Erlangen, and he's also the dean of the medical faculty. So, yes. So maybe we start off with the first question to the biochemists around us. So Anja, Randy. So you are biochemists, and biology-biochemistry interface is very well established, has made very powerful breakthroughs in the last couple of decades. What do you think of the physicist's ambition to research at another interface? Do you think this makes sense?
I like the Nobel Prize winner start.
Well, history is a guide, and obviously, since you've set this up, it's true. I mean, look at what physics did for optical microscopy. I mean, the revolution in the past 15 years and our ability to visualize things at nanometer resolution is, quite unexpected and dramatic.
Yes, there was technology development by physicists.
Yeah, but as we heard earlier, according to Sidney Brenner, technology is often what starts innovation.
Good point, yes.
So extending it just a bit to computation and AI, the triumph even more recently of DeepMind and AlphaFold is to use computation based on the discoveries that have already been made to predict the structures they deposited 2 years ago online. 250 million predicted structures, many of which now guide experiments that, in laboratories that wouldn't know how to form a crystal if they wanted to. So I think the opportunities obviously extend beyond that. And
so you don't mind us invading the field?
No, of course. You're more than welcome.
Excellent. Anja?
Well, the same opinion. I think you clearly shown in your 5 talks how you integrate into the field, and I think we need all the interfaces we can get to answer these basic questions. we've got so many questions, we've got so many cartoons that White showed us, which we really have to understand the details. And I think we need more interdisciplinary research, really, defining new problems and thereby defining new answers. And this is what is still lacking here.
Okay. Along those lines, Joachim, a question for you as an expert in AI. Isn't AI the key to everything? Isn't you know, there is AI designed drugs, AI can connect molecular patterns. Do we really need physics?
If you ask politicians, you might get the answer, AI is the solution. Actually, AI is an important tool that supports the researchers a lot because you can deal with a huge amount of data. You see links in the data that you won't find out if you do it by hand. So it's a very, very powerful tool. And it also helps you to do predictions. That's something that is important, in particular, if you have to deal with a combinatorial explosion of different varieties that you can generate. So I consider AI not as the solution, but as an important tool that can be combined with all the deep understanding that people in physics have of those processes. And I think it's very important that in basic research we still keep on track to try to understand actually what is going on and avoid data-driven model as the solution without reconsidering what's actually the physical principle that is underlying these.
So fundamental approaches are still important. Yes.
They, of course.
Yes. Thank you. We've chosen our discussion partners very well. Markus, you're director of a clinic. Does medicine need physics?
I hope so.
You've been very successful.
Well, I think we have learned over the last decades that physics is extremely helpful in medicine. Think about PET CT scans, MRI physics, and so on. Think about the breakthroughs in microscopy technologies, which is quite amazing. And I think in the clinic, most of us work on inflammation and cancer. And one key issue in the clinic is really personalized medicine. So we understand that the disease behaves different between patients. And I think we really have to look into the tissue. I think that's the next step forward. And that's where this center will help us by developing new technologies, allowing us to look at the movement of cells, the migration pattern, the stiffness of cells, the exit from the tissue. And this will lead to entirely novel concepts, how inflammation and cancer develop and progress. And I think this will lead to new ways for diagnostics and also for new ways for therapy. So we are looking very much forward to interacting with you.
So do we, yeah. Excellent. And Karin, vice versa. You as a physicist, does physics need medicine?
It's the arrogance of the physicist to say no. But, well, if you break it down, I mean, physicists say everything is physics. If you go to the orbital level, to the molecular level, even chemistry is physics on that level.
And biology is chemistry.
So, but physicists like to live long, and therefore they need medicine anyway, right? So, and the medicine students, they have to do physics, but not for nothing they have to do physics. Mm-hmm. But if you bring these two people together, as always when you cross disciplines, new things can happen. And so I think teaming up these two kinds of people are also really two kinds of people, because the old joke, there's the telephone book. You give it to a physicist and he said, what should I look up? And you give it to a medicine student and he said,
should I interrupt
this
now? I know where it's going.
Shall I take it by heart? So these are two disciplines that come together. And if you look at these things, like you showed it, they're so complex. Not a single scientist can be at the front of science in these two disciplines. So if you team up these people who both follow up the new achievements in each of these subjects, and then bring them together, and then they find friends, you have to work together, you need to become somehow friends, right?
Yes.
And I think this is something that is really special here and that can make a boost. So I'm really envying you as a physicist.
Yes. I think the learning thing is a bit of a preconception, though. Being a veterinarian myself by background, so yes, but otherwise, yes. Okay. So do you think understanding the human body may be the final frontier of physics?
It's one of the frontiers, but it's really going forward in the mesoscale. So there's this saying, life is at the mesoscale. And you can look at Wahid's curriculum. He started at the molecular level. He was doing things with photons. Photons are one of the smallest things you can have. And then moved into larger things to look with those photons on the mesoscale. Mesoscale is something between clusters of molecules and an entire cell.
Yes.
And this is the mesoscale. And the mesoscale in physics is extremely important. It's the one of material science, It's the one of microfluidics, where you have turbulence on very small scale, not on this big scale like rivers, but you learn from both sides, and at the mesoscale they meet. So I would say the mesoscale is the frontier of science and physics.
And I guess you would agree that this is the scale that matters, right?
Oh, of course.
All right. So switching from science questions to more higher level questions. At Joachim, maybe. So question for the president of a university. We bring together, or we try to bring together very different areas of research, so from very fundamental to applied, with three different, very different institutions, so with different infrastructures, different mindsets, potentially even different text law interpretations. Is it worth the effort?
I'm biased, so yes, it's worth. Of course, I mean, FAU in particular is a full spectrum university. I mean, interdisciplinarity and the collaboration between multiple disciplines is something that we have in our strategic focus. And we are convinced that at the boundaries between the different disciplines, there is a huge push for innovation. And we try to build up an environment here with all our partners, also our non-university partners like Max Planck, an environment that really fosters this type of collaboration. And this is also supported by our hiring strategy. If you look at the people that we have hired over the past to support this particular link between physics, medicine, and sciences.
Okay. Yeah. And so, yeah. I think the future will tell if it was worth the effort, but I very much hope so, yes. Science policy question. So maybe for somebody who was on the Wissenschaftsrat for a couple of years, do you think the joint efforts of university and Max Planck and a clinic makes sense? Can this joint venture add to what's otherwise possible?
Yeah, I think a joint venture is strongly necessary because while we're all researchers, we know that interdisciplinary research is quite tough. So it's a lot of effort. It's much easier to stay in your small bubble and do your highly disciplinary research. But to go be joint, to trust other people that they have the knowledge in this field and they guide you and you together develop something, and to learn the language of the other, which, you five learned this. You gave fantastic talks where we all know what you're doing, but you could do it differently. You could have a lot of mathematics and stuff on there where we all were just gone. So this is how you convince others to work together, learning language, trust, doing this, and this is effort. And I think researchers need help to do this strong effort, and this is a big help to do interdisciplinary, really, really high-level research, being together and somehow next door to each another, and then you can do this. And so I think this is the way to go, with consortium buildings bringing people also together.
So might this be the future, or like this kind of consortium, this kind of joint venture, or over standard university research, or?
I wish it would, but I think it's the money that prevents us from doing so. But I think it brings together and acts positive on all the positive sides of each of the entities have. So without the clinic, you wouldn't get patients' tissue or anything, right? Yes. So without the Max Planck, you wouldn't have this big institute around, with all directed into one subject, with all the appliances, the technical people, the instruments, the labs, and so on. Mm-hmm. And from the university side, you can punctually just call somebody and give a certain room for a lab, but you would never have, like if you have a Max Planck in the back, it boosts this. So to make it to make the impact of a Max Planck larger, this is the way to go.
Okay.
Can I add something?
Please, yes.
Well, it's not just money. It's also the barriers to meaningful collaboration. You know, unfortunately, the reward structure in academic science favors the individual. It's, you know, where you publish or where your name appears on a list. In the US, I don't know if that's true here, but assistant professors who have a very powerful technique that they wish to use in collaboration with other groups may end up publishing lots of papers where their name isn't in a prominent position, but they've contributed an essential part of the project. And these people, in spite of obvious productivity, often have difficulty reaching a level of tenure because you know, the question arises on a panel, what did he or she do? Well, you know, the work wouldn't have been possible without this individual.
Yes.
So I think what needs to happen is that there needs to be a way of recognizing that kind of achievement and not just the individual achievement, the collaborative achievement, which is in some ways even more important. There really are no effective means of rewarding that kind of collaboration.
Yes. Fully agree. Yeah, there are a couple of things in science that need to be thought about.
A couple
deeply,
of things.
yes. But this is a very important one, absolutely, yes, I agree. So there is, I think we agree that there's lots of opportunities now here. But there's also challenges, I guess. So Markus, how can we together establish as many collaborations as possible? How can we foster exchange between clinics? I mean, in these neighboring buildings, but there is still a few 100 meters between, which is an energy barrier.
Yeah, but I think it's a doable distance. So I think the key difference between this campus here and other buildings for physics and medicine is that you are really located in the heart of the medical campus. And I think that gives you a unique access to patient samples, to patient care, to interaction with medical doctors. So if you go out to drink a coffee, you stumble into medical doctors if you want or not. So you will interact, you will talk to them, and I think this will be quite fruitful and bring up new ideas and new concepts. And I think it's a key difference between this place and other places where you have to travel, 10 miles across the city to get to a physics center.
Mm-hmm. Absolutely, yeah. Sounds good. Randy, question for you as an editor or former editor. What are the challenges with publishing work between disciplines?
There are many challenges that I, for one, have not been able to tackle. And I think it's getting worse, frankly. I think the hegemony of the largely commercial journals has had a toxic influence on scholarship. Young people feel that if they don't have a paper in Cell, Nature, or Science, or one of their offspring, they won't have a career in science. And yet the way that papers are reviewed by these commercial journals in particular, I think, creates part of the flaw. That, for instance, at Nature or Science or Cell, papers are, the decision about whether a paper is reviewed or published is made by a professional editor. Not to disparage these people, but they used to be scientists. They were trained. Then they're called on to handle papers that are far beyond their own expertise. And they are ill-equipped to make judgments, so they get a number of disparate remarks from referees. They are incapable of making a critical distinction among the remarks, so they send it back to the author and they say, well, fix it. And you see with a Nature paper, it comes in, maybe 2 years later it gets published. Is science served by that? I don't think so. Frankly, I don't think these commercial journals are serving science well. I personally feel that work from my lab, I want to have it reviewed by people who are active scientists, who have critical judgment and know when a referee is making up nonsense and may not need to be considered. Yeah. Professional editors are incapable of doing that. And this is a whole further discussion because of the positive force of Coalition S, a largely European group, and Plan S. The commercial journals have finally been forced to succumb to the pressures of open access. This has been a long battle. They fought against this for years in the courts and in legislative sessions, and they continue to fight it. But those of you who publish in these journals now will realize you're paying the price for having won the victory. It costs the equivalent of $11,600 to publish a paper in Nature or any of the journals that have the Nature name on it. Is that the real expense associated with publishing in Nature? No, there's a huge profit that's made by a wealthy German family that owns Springer Nature. The same is true for Elsevier. Elsevier is the largest commercial publisher of science in the world. Their profit margin is one of the largest of any corporation in the world. And it's because, they rely on our free labor to do their work for them, and they charge on an arm and a leg. And I'm afraid for those people here who are charged with making decisions about funding science, we're being ripped off. And I'm afraid that people who don't have enough money from public funds, would pay out of pocket because of the pressure they feel to publish in these commercial journals. So I'm sorry to have to go on about this, but I think
an important point.
I think this is the way that these professional editors judge what gets published is they're looking for the next shiny object, and that drives science in ways that might not be best for scholarship.
Yeah.
May I add something here?
Go ahead.
Go for it.
The German Science Foundation has modified the forms in which you plug in your CV. And in the publication row, you are only allowed to give 10 publications, and you are allowed to give comments. So if you are a middle author of something, please write why you are there, what was your contribution. If you are in an unknown diamond open access journal, just write, what are you proud of? Just to break this dominance of these commercial publishers. So please make use out of this.
Let me make a brief remark on a positive aspect of interdisciplinary collaboration. Interdisciplinarity means that at least two people collaborate, and my experience is if you have a strong researcher, he only collaborates with strong researchers, so they pair up, and you get even more out of that. And in terms of publications, you have two experts in their particular field, and they work on a problem that is relevant for both fields and generate scientific results. And so you can publish this also in both communities, and you have a multiplier effect. That's actually what I have observed. And this, for instance, leads to situations like one of our engineers is the most referenced ophthalmologist in Germany, Austria, and Switzerland. And this sounds weird, but these are the things that happen if you have this type of interdisciplinarity. So I'm really encouraging people to collaborate because the strong ones collaborate and push things forward, and not the strong one with the weak ones. Yeah.
Yes. And science funding, let's say you get collaborative research center applications in the medical initiative, and there is 9 that are translational or clinical, and then there's 1 which is dominated by physics approaches. What is the chance?
This is a good question. I have myself worked in a collaborative research center that is very interdisciplinary, going from physics to medicine, and we needed a second attempt. Because we got once as a comment, okay, if you can describe the tumor theoretically, you cannot make it vanish. And this was, this was in the critique of the protocol after the assessment of the CRC. And this broke our neck. And then we said, we need to do something here. And so, for instance, therefore, we have 2 Fachkollegium, biological physics and physical biology. First. Second, the thing is, if you have the kidney and everybody is on the kidney, or really famous are the astronomers, they're always excited. All the reviewers are excited about the kidney if there's a kidney CRC, and also the astronomers. So very likely the protocol will be absolutely enthusiastic unless they have done something wrong. So with the interdisciplinary things, you will always have some bit of critique that everybody could just speak from the reviewer and add something. Not because they don't like it, but because they want to make it better. So you just have to live with it, because the panel that is assessing the CRC grants now has learned as well. to see if there's, a big return on investment. And on those interdisciplinary collaborative research centers, typically the return is really, really large. So often these monodisciplinary CRC now lose because they are not so exciting. They cannot excite the panel that much as if two sides that are really difficult or different come together. Okay. And I can just say, if you do something, make use of the right that you can propose reviewers. Because it's really important that you get reviewers that work, that have this one eye on one discipline and one eye on the other discipline. So former times it was such that you got people from engineering and people from medicine. And then it went wrong because they were not really doing research themselves on that interface. So this has changed in the past 20 years.
So we have a chance if we're lucky with the reviewers, as usual.
Big chance. People will be thrilled.
I mean, given the environment here, where like as Joachim already mentioned, that the physicians, they are very open-minded. We have a pretty good chance of submitting a couple of those in the near future, I hope. So, question to Markus, as the dean now of the faculty, why are so we are all amazed and puzzled by why the clinicians here, why the medics, why they are so open-minded and why they are so research-driven, curious. This is no. What's wrong with you guys? But how do you manage? How do you manage to establish such an amazing culture?
That's a difficult question. Obviously, there must be something special in the air here. No, I think you just have to have an open mind. And we took, as a medical faculty several years ago, the strategic decision to get closer in contact with our faculty of natural science here at FAU and with the technical faculty. And when Wahid joined Erlangen, it became clear that biophysics is a key area for interaction. And I think we have been in contact. We have recruited new professorships to the campus. We have erected this new building. We have even now new research buildings coming up for artificial intelligence next to this building, and also for biophysics and immunology, also adjacent to the center. So we have now, in a way, a translational chain, which will allow us to bring ideas from the clinic here to the center and also back into the clinic.
It was an excellent idea, I would say. Yes. Right. So these physics and medicine interface is not the first time that it's attempted, right? There was an attempt in Cambridge which failed terribly, like a couple of years ago. But there was another attempt in the US, and the question for Randy. So in the US, like 15 years ago, the NIH National Cancer Institute started a huge initiative to link physical sciences with the study of cancer. Mm-hmm. This was pretty much the first time that biologists were asking physicists for concepts and not just for new technologies. I mean, these centers, there's, I think 12 centers or something have been formed. They're all virtual, as far as I know. So there's not a building like here. But what would you call this success?
Well, I'm not familiar with the program, but I am familiar with the NIH effort to create centers of excellence where they have teams collaborating.
Yes.
So let me just take a couple of minutes to explain the context. When I stepped down as the editor of eLife, it was because my wife had died of Parkinson's disease, and I was asked to start a new program to support an international collaborative effort on Parkinson's disease, funded by the Sergey Brin Family Foundation. Mr. Brin, co-founder of Google, very wealthy, but he has a family genetic history of Parkinson's, so he has a keen interest in doing this. So he's invested hundreds of millions of dollars in this effort, and as a result of this initiative, we have built up a network of 163 laboratories organized into 35 teams, and the team is the critical thing, and that relates to what I spoke about earlier about collaboration. So whether it's physics or cell biology or biochemistry or anything, the sum has to be greater than the parts. And governments, I have to say, traditionally are not very effective in monitoring whether collaborations are really meaningful. So the US NIH set up, in respect to this program that I'm involved in, US NIH set up programs for Parkinson's disease at medical centers where they recruited 7 to 10 investigators to work together. And unfortunately, you know, clever investigators come together with the smell of money, and they write grants, and they get funded, and they may start off with the best of intentions, but they end up retreating to their own laboratory, where they just rely on the money. So for any collaborative effort at that government scale, there has to be, I think, there has to be follow-through. And so what we've done in our program is we have ways of not just encouraging collaboration, finding people who really have that innate interest in collaborating, but in ensuring that the outputs are measured in terms of collaboration and not merely in Cell, Nature, and Science papers. And that takes a lot of work, and it takes resources to do that. So I can't speak to the success of that program funded by the NIH, but I would be very cautious about those kinds of centers that to which people apply and get money and then retreat to their own laboratories without a mandate to have meaningful interactions.
That's also what happened in Cambridge when it went wrong. I think what we have here, everything in one building, at the heart of the medical campus, I think this is key to success. Future will tell, but we have pretty good chances to succeed.
But there have to be ways of measuring collaboration and not just papers that are published.
Yes, absolutely. So last question maybe for Joachim as the president of the university. So beyond the immediate research and the outcome, whatever it may be, publications, treatments, diagnosis, or just fundamental research, do you see any other opportunities or challenges for the center?
Well, one huge opportunity is to grow the next generation of students into this type of interdisciplinary collaboration. I mean, being in the hospital, meeting a physicist, I mean, that's great. A student of physics or a computer scientist or electrical engineer. So we can really define the next generation of researchers with our education programs, and the university has also a huge opportunity to adapt the education program to this unique environment that we have here. And as Joachim has already mentioned at the beginning, this is a unique selling point for us here at FAU here in Erlangen, but worldwide there is nothing that is comparable to this type of setup that we currently start here.
Okay, great. I think this is a very, very wise words. And probably a good point to close this session. So basically, just to summarize, I think we all agreed that physics has a good chance to contribute to medicine.
Yes, yes we do.
Surprise,
Surprise. Today in here. But what's important is to have an environment which is collaborative, which is communicative, to talk to each other, to learn the different languages between medicine, physics, engineering, chemistry, biochemistry. And we have this environment here, we have this building, which is an amazing opportunity.